Okay. So, good evening, everyone. Welcome to this live session on 25th to 2026. Okay. So, we'll be discussing the week 3 content and some examples followed by some problems followed by this content. So basically week 3 content, so it deals with the basic called as the transfer function and block diagrams. Okay, so it deals majorly these two topics. So first, I'll explain briefly what exactly the transfer function is. So let's say consider an nth order uh, linear time, okay, linear time invariant to dynamic system. Okay, so let us say how does that looks like a naught y plus a1 dy by dt plus a2 d square y by dt square plus etc plus an dn y by dtn equal to, so similarly this side b naught u plus b1 du by dt plus b2 d square u by dt square plus etc. So last you have bm dmu by dtm. Okay, so in general any dynamical system can be written in this nth order uh, differential equation. Okay, so let us as you know already, let us consider, so for this case let us consider all initial conditions are zeros. All initial conditions are zero. So all initial conditions zero means what? With here the y is the u is the input and y is the output. Okay. So if you take up all these initial conditions zero, okay, and apply the Laplace transforms which we saw in the previous classes. So apply Laplace transforms. So what do we get? So starting here, a naught y of s plus a1 s y of s plus a2 s square y of s plus etc. The last one is an s power n y of s equal to, so the right side is b naught u of s plus b1 s u of s plus etc. The last one is bm s power m u of s. Okay, so how do we get this? So basically, for example, if you take up this one, Laplace transform of what is dy by dt, that will be like s y of s minus y of 0. Okay, so here since the initial conditions are zeros, okay, so the y of 0 is 0. Initial condition 0 means what? Let me write it here clearly. So initial conditions 0 means, okay, so y of 0, y dash of 0, y double dot of 0, etc. All these are zeros. Okay, similarly u of 0, u dash of 0, etc. all these are also zeros. That's the meaning of the initial condition 0. Now in this case, initial condition y of 0 means you will get Laplace transform of dy by dt is s y of s. That's why I've written here. Okay, similarly you can apply the in the similar aspect, similar way for the all other powers. Now if you take up this function, so you will get y of s by u of s. Okay, so how does this look like? B naught plus b1 s plus b2 s square plus etc. The last one is bm s power m divided by what, a naught plus a1s plus a2s square etc plus an s power n, correct? An s power n. So if you see this, okay, so this has numerator n of s and denominator d of s. Okay, so in this expression, let me take this one. So if you are getting any doubt in the middle, you can always ask me. Okay, so let me call this as the g of s. Okay, so g of s. Now suppose if you take this here bm common and here an common, so what do you get? Here you'll get s power m plus, okay, so this is bm minus 1 by bm plus, so this will be s power m minus 1 etc plus b1 by bm s plus b naught by bm, correct? Similarly here what do we get? S power n plus bn minus 1 bn s power n minus 1 etc plus b1, sorry, that would be a, I'm sorry, this would be a. So an minus 1 an, so a1 by an s plus a naught by an. Hope this is clear. Okay, so how do we write this one still? So this bm by an, I'll take that is as k. The rest of the terms I'll write it is as sm plus bm minus 1 bar. Okay, so s power m minus 1 plus b, etc. The last one is b1 bar s plus b naught bar. Okay, so similarly I can write here s power n plus an minus 1 bar an minus 1 plus a1 bar s plus a naught bar. Is this clear? Any queries? Now I can write this as, so the numerator I can factorize and put them like this. Okay, etc. How many? M terms. Okay, similarly denominator I can put like s minus p2 etc s minus pn. Okay, so here, so assume that so m is less than or equal to n. Okay, so now you can see here, you can see here, so the numerator roots. Okay, how do we get the numerator roots? When you take n of s is equal to 0, you will get z1 z2 etc zm. When you take d of s equal to 0, that is denominator, you'll get p1 p2 etc pm, correct? So these things we call them as zeros, these things we call them as poles. Is it clear? Any query as of now?
Sir, are you considering unit step function here?
No, this is not unit step. I told you, no, this is unit. Y is u is the input.
Okay.
Don't think like u is unit step. So it is u is the general input. Okay, so for any system, general differential equation we write in this form in terms of its output and input. Okay, then I'm applying the Laplace transform, then we end up with this expression. Okay, in this expression, if you take numerator equal to 0, we are getting z1 z2 etc zm. Denominator equal to 0, we'll get p1 p2 etc pn. Okay, so specifically we are taking m is less than or equal to n. Okay, we call this particular equation when you take d of s equal to 0 as characteristic polynomial. Characteristic polynomial. Okay, is this clear? So simply, what is the meaning of this pole and zero? Okay, suppose here in place of s, if you substitute z1, what happened to the entire expression? Can anyone tell me?
0.
The entire expression becomes 0. Okay, in place of s, if you substitute any of these z1, z2, etc., zm, so the entire expression goes to 0. That's why that is called as the, each of these called are called as the 0. Okay, similarly in the denominator, if you substitute p1 or p2 anything expression, so what do we get?
Undefined.
We get to infinity. Okay, so that we call them as the poles. Okay, so these are the zeros and poles. Okay, is there any doubt? So zeros you will get when you take numerator equal to 0. Okay, poles you will get when you take denominator equal to 0. Is this clear? Any queries? Anyone? Okay, so that's the first point. Okay, so after finding zeros and poles, generally what we do is, so here this we call this is as the transfer function. This expression is the transfer function. So transfer function is nothing but what? Laplace transform of output divided by Laplace transform of the input. Okay, so uh, it is not the basic definition. Okay, so it is the Laplace transform we define, the Laplace transform, sorry, the transfer function we defined as the Laplace transform of the output divided by Laplace transform of the input under when these initial conditions are 0. That is very important. Is this clear? Any queries? So the definition of transfer function is Laplace transform of output divided by Laplace transform of the input under when all the initial conditions are 0. Okay, then we find this expression numerator and denominator, we find the poles and zeros. Okay, so now, so any queries? Any queries? So no queries. Okay, so yeah, so now what we will do is we'll start with simple functions. Let us say, so let us say if uh, the, let's say this transfer function g of s is 1 by s. Okay, can you tell me the poles and zeros in this? Can you tell me the poles and zeros?
So there is no 0.
There is no zero, no zero. Okay, so pole is
Only it's at s equals to 0.
p equal to 0. Okay, so only one pole, that is p1 equal to 0. Is this clear? Yes. Okay, so now what we do is once we get to know the poles and zeros, we take this S plane. Okay, so we call this is as S plane. Okay, this S plane will have the real part of S and then imaginary part of S. Okay, so real part of S is the x-axis, imaginary part of S is the imaginary of S, that is y-axis. We call this one also or j omega axis. This one is sigma axis. Okay, so now then after that what we do is we will represent. Okay, so we will represent these poles and zeros on this plane. So there are no zeros. Where we have the poles, we have pole at 0. Okay, so we represent pole with cross mark. Okay, so 0 on S plane, S plane. Okay, so 0 we represent with the circle, pole we represent with the cross mark. Okay, is this clear? Any doubt? So this is, we call this is as a pole 0 diagram. So pole 0 diagram. Okay, so now we have this G of s as 1 by s. So what is z of t? Can anyone tell me? So 1 by s is nothing but what? That is the Laplace transform of u of t, correct? So what is its expression is? This is t, this is g of t. So the expression is like this, correct? Okay, any doubt in this? So what we are trying to do is, given transfer function, we are writing what are the poles, what are the zeros, and representing them on the S plane and writing its time domain function. Is this clear? Is this clear?
Yes, sir.
Yes. So next, okay, let us consider one more so that you will understand better. Okay, so I'm taking let's say my g of s is b by s square plus b square. Okay, b by s square plus b square. Now tell me the poles and zeros. So again, there are no zeros. So no zeros. Why? Because there is no s function in the numerator. So how many poles we have?
2 poles.
So can you tell me p1 comma p2?
Plus minus
Yes,
JB.
simply what we do is we take characteristic equation. Characteristic equation means d of s equal to 0. Okay, so what is d of s? S square plus b square equal to 0. So that means s equal to what? Root over minus b square, correct? So that will be plus or minus jb, correct? So that will be like plus jb minus jb, correct? So now if you plot on the S plane, what do you get? This is real part of S. This is imaginary part of S. So now you see you have plus JB minus JB. Where do we have? So I'll call this is as, yeah, that's correct. Imaginary part of S. Okay. So plus JB is here, minus JB is here. Am I correct? So this is S plane, pole zero diagram. Okay, so now again if you plot the g of s b by s square plus b square, if you plot g of t, what is it? That's going to be sine bt, correct? Okay, so that is the Laplace transform of sine bt. Again, this is t, this is g of t. How does it looks like? So it looks like sinusoidal function. Am I correct?
Yes,
Yes.
sir.
Yes.
So that's how it looks like. So when the poles are on the j omega axis, this function becoming sinusoidal. Now let us take one more. Okay, so let us take uh, let's say g of s equal to s plus a by s plus a by s plus a whole square plus b square. Okay, now tell me the zeros. That is minus a. Am I correct?
Yes.
So poles p1 comma p2 is, so minus a plus jb minus a minus jb. Am I correct? Okay, so let us consider here a greater than 0, b greater than 0, let us say. Okay, so now tell me the S plane. Okay, so if a is greater than 0, b is greater than 0. Okay, so this will, where does this will stay? The pole minus a will be somewhere here, correct? Am I correct? Minus a plus jb. Sorry. Yeah, so minus a plus jb. So this is the pole p1. Am I correct? The p2 is minus j minus jb. This is p2. Is this clear? The pole we represent with the cross mark. the 0 minus a, that we represent with the circle. Is this clear? Yes. Okay. So now again plot the time response. This is time, this is z of t. Now can anybody tell me what is g of t? That is this is the Laplace transform of e power minus at cos bt. Am I correct?
Yes, sir. Correct.
Yeah. So how does cos bt looks like? Cos bt looks like this. Am I correct? So it starts at minus 90. Okay. How does e power minus at looks like? E power minus at looks like this one. Correct? For a positive, it starts at some point, it's keep reducing. Okay. Now, okay, if you are multiplying these two, this is okay. If you multiply these two, how does wave look like? So you will get a wave. Sorry, you will get a wave from here. Clear? This is your z of t. Is this clear? Okay, so the waveform would be something like this. That goes in this envelope. Okay. Now you could see there is this guarantee that it will become zero somewhere. Correct? Yes or no? Whereas in this case, it will never be zero. Why? Because the envelope would be like this. It will keep continuous. Okay. Is this clear? These three cases. Any queries? Okay. So now what I do is, so you have to tell me how does response looks like. We will go in general. Okay. I'll locate the poles. So I'm taking the bigger picture. So this is real axis, real of s. This is imaginary of s. Okay. So I'll take the poles at different locations. Okay. Only poles. I'm not looking at the zeros. Okay. So now tell me. So let's say we have a pole here. Okay. What is its time domain response? Can anyone tell me? Can anyone tell me? Pole at 0.
UT, UT.
Ut. Okay, so the ut will be like this. Okay, so ut will be like this. Am I correct? So this one belongs to this. Correct? Yes or no?
Yes,
Okay.
sir.
Now let us say I have pole here. Now tell me. Now tell me. So you clearly know that. So we call this is as S plane. Okay. With respect to this imaginary axis, we call this is as a RHS, right hand side of S plane. Okay. We call this is as LHS, left hand side of S plane. And we call this is as J omega axis. Okay, it means that with respect to J omega axis, we'll have right side and left side. Okay. So now can you tell me anyone? So what about this?
E to the power minus 80 into ut.
E power minus 80. That means, so as the time increasing, the response goes to 0. Why? Because if you take this is as some minus 2, what is its response? E power minus 2t, correct? As the time gets increases, the response goes to 0. Am I correct? Yes or no?
Yep.
Okay, so that is this one. Now similarly, let us say I have same similar point this side. Now can you tell me about that?
e to the power 80.
E power 80. So it looks like what? It starts here, it goes like this, correct? Yes or no?
Yeah.
E power 80, let's say if you take 2, e power 2t as time, e power 2t as time is increasing, the value gets keep on increases exponentially. Is this correct? Okay. Now, okay. Now, I'll take one pole here, another pole here. Can you tell me now? Only these two pair, this pole, exactly at same, just reflection only. Can you tell me how does this response looks like? How does that response looks like? Same thing we have seen already this one, correct? Yes or no? We have seen already. Okay. So how does that response looks like? It looks like sinusoidal. It looks like sinusoidal. Okay. Just take. Is this correct? Is
Yes.
this correct? Right? Any queries so far? Any queries? Okay. Now
Sir,
suppose, yes,
sir,
yes,
for,
yes.
for 2, GS equal to 1 by S minus 2 or S plus 2, that will be unit function of shifting 2.
No. GS equal to what? 1 by
1 by S plus 2.
S
Then
plus
the
2.
pole,
What is
yeah,
the pole? Minus 2.
yeah. Or
What is
S
G of t?
minus
What is
2.
G of t is e power
2
minus
minus
2t.
2.
That
Yeah,
will be this one.
yeah.
Okay.
Yes, sir.
Yeah. So now, can you tell me any other options where I can choose the poles? I'll choose somewhere, let's say I'm choosing here, not on real axis or not on imaginary axis. I'm choosing somewhere here. Now tell me. So assume that the distance is same from real axis. Now can you tell me how does that looks like? How does that looks like?
A damped oscillation.
Yes, it should looks like this. Okay, is this clear? Okay, now similar case, I'm choosing another here. How this one looks like? How this one would look like? This would look like exactly opposite. Am I correct? Yes.
Yes, sir.
Okay, now you see left side and right side. An interesting case. Okay, so what did you observe? Left side plots and right side plots. When the poles are on the left side, when the poles are on the right side, and when the poles are in the on the j omega axis. So what are the cases when the poles are on the left side? Okay, so this one, this one, correct? That means this and these two responses. What is happening in these two responses?
All goes to 0.
All goes to 0. Whereas their their opponents here, this one, this one, this one. What is happening?
Goes to infinity.
They are they are exponentially increasing. Okay. So we call when all the poles are existing on the left side of the j omega axis. Okay. So we call them as the stable. Okay, we call them as the stable. Okay, so this side is unstable. Is this clear? So only real part has to be negative for stable system. For unstable system, only real part has to be positive. Okay, imaginary can be anything, because here imaginary is positive, here imaginary is negative, correct? So that will not affect. Is this clear? Okay, and when the third case, when the poles are existing on the z omega axis, okay, so which response it is? This response. Am I correct? That is belongs to these two poles. Okay, so we call that is as marginally stable, this one, these poles. Marginally stable. It means that their response neither decreases nor increases. Is this picture clear, everyone? Is this picture clear?
Yes, sir.
Yes.
Clear.
Yeah. So if you are not clear, still you can ask me. If it is not clear, you can ask me. Okay, so that is how from the transfer function we find the poles and zeros, and based upon the poles location. Okay, so for example, so let's say we have transfer function as s plus 2 by s plus 3 s minus 1. So can you tell me the poles location now? Can you tell me the poles location?
Minus 2,
Minus
minus 3
Minus
and
3,
1.
1. Okay, and zeros location?
Minus 2.
Minus 2. Okay, so system stability will be depending upon only on the poles location, not on the zeros. Why? Because so this function I can write it like how a by s plus 3 plus b by s minus 1, correct? So this I can write it like s plus 3 using partial fractions, s minus 1. So this is a multiplied s minus 1 plus b multiplied s plus 3, correct? So now both sides, what do we have in the numerators? Here we have s plus 2, here we have this one. Okay, so if you compare the coefficients of s, what do we have here? 1, correct? What do we have here? A plus b, am I correct?
Yes,
And
sir.
if you compare the constants, what do we have here? 2. What do we have here? Minus a plus 3b, am I correct? So
Yes, correct.
now if you add them, okay, so these two gets cancelled. Okay, so what is it? 3 equivalent to 2, 4b, correct? So b is 3 by 4, am I correct? Then what is a from this? 1 minus 3 by 4. 1 minus b, that is nothing but 1 minus 3 by 4. What is it? 1 by 4. Am I correct?
Yes, sir.
So now g of s, how can I write? So that is 1 by 4 by s plus 3. Okay. Okay, so I can write it like 1 by 4 multiplied s plus 3 plus 3 by 4 multiplied 1 by s minus 1. Now can you tell me g of t? Can you tell me g of
E
t?
to the power minus 3t.
So 1 by 4 e power minus 3t plus
1
3
by
by
4.
4 e power t, correct? Yes or no? So what is the time response now? So time response is 1 by 4 e power minus 3t. Okay, so that means it starts at 1 by 4. Okay, it keep reducing. Why? Because of minus 3t, correct?
Yes, sir.
Now the other one is 3 by 4 e power t. It starts at 3 by 4 somewhere here. Okay, it increases like this. Am I correct?
Yes, sir.
So now you are adding these two. Okay, when you add these two, what will happen?
It is still
So
increasing.
the resultant would be somewhere like here, and it increases. Okay, this is g of t. Am I correct? So now what is happening overall system?
Unstable.
Overall system is unstable. Why? Because of this pole here. Correct? Instead of plus 1, if that is minus, if instead of minus 1 here, if that is plus 1, what will happen? Here you will get e power minus t. Correct? Yes or no? Instead of minus 1, if it is plus 1, here you will get e power minus t. So in that case,
It
so the
will be.
overall system gets decreases. Okay. So if it is plus 1, it means that the pole will be having the left side. Is this clear?
Yeah.
So 0 location is not affecting much. Okay, directly by seeing the poles, whether they are on the left side or right side, we can declare the system is stable or not. Clear?
Sir,
Yes.
I can't understand GT here. Adding by adding e to the power
Yes.
minus 3t and e to the power t.
Yes.
How it is going upward? That is
No, no, you'll be adding these two terms, no?
okay.
Yeah. So this is not reducing. This is reducing. Okay. It may not go upside, but it will not come 0
Okay, okay. Yes, sir. Yes, sir.
because of this term. Okay. So that's how it looks like. Is this clear? So based upon the pole's location, you can directly declare whether the system is stable or not. Okay. So generally what we do is, for any system, first we write the dynamic equations in this form. We also call that is as the modeling. We call that is as modeling. So once we model the equations, then we apply the Laplace transforms. Then we find the transfer function. Okay, once we have this transfer function, then we'll find the poles and zeros. Then we'll talk about system is stable or not. Okay, in control systems, this is the procedure. We find the poles and zeros. Okay, then we talk about system is stable or not. So in this case, to make the system stable, what is our requirement? What is our requirement here?
Pole will be at negative pole.
Yes. So this should not be on the right side. Okay. Only thing is that we should move this pole 1 to the left side. Okay. That's what the main job of this control systems course. So there are in the next modules, we are going to see these controller designs. So which some controllers will push this pole to the left side, and some controllers will add so some kind of zeros on the left side, which will nullify the effect of one, something like that. Okay, that we will see in later of the courses. So okay, I hope this finding poles and the zeros concept is clear to everyone. Okay. Yeah. So
Sir, we
next
need to
yeah.
find GT in every questions like.
Sorry, no, ZT you're finding to just to check.
Okay, sir. Okay.
Yeah, yeah. So just here itself we can decide just by looking at these two poles. So GT time response we are seeing. Okay. So by looking
Okay.
at the
Okay,
time
sir.
response, we can decide. Okay. So yeah. So now, so we'll consider one electrical system and try to see how to find this transfer function. So the modeling part we can do for any system. We can do for the mechanical system, we can do for electrical system, we can do for the gear systems, we can do for biological systems. For any system, we can do the modeling. So for some of the systems, so Professor, as I already explained in the video, you can go through them. But as of now, we'll try to solve one problem here. Okay, so quickly, example, we take the electrical circuit. So let's take,
Excuse me, sir.
yes.
Before this, could you please tell me that how you draw that GT in previous
Uh,
question?
which one? This one?
Yes, sir.
So this is your question, correct?
Yes,
So
sir.
first one is this part. Okay, this starts at when you substitute t is equal to 0. Okay, this will become 1 by 4, correct?
Yes, sir.
E power 0 is 1. So it starts at this. When you keep on increasing t, it reduces. At t is equal to infinity, it will become 0.
Yes.
Okay.
Yes,
Then
sir.
second part is when you substitute t is equal to 0, it will be 3 by 4. Okay. When you keep on increasing t, okay, it keep increases instead of reducing. So it goes like this, correct?
Yes, sir.
Now your zt is nothing but what? Gt is summation of these two at every instant of time. Okay.
Yes, sir.
Do you expect that it will come to 0 at any time?
No, sir.
No. So it never comes to 0. It may be in the middle somewhere. Okay. So it keep increases as time as time goes to infinity. It never comes to 0. That's why it is unstable system. That the same thing you can decide by using this pole, because pole is on the right side. Okay.
So for any signal, will it be enough to say that if the
Hmm.
one pole is at the RHS, then it will be
Yes, yes, yes,
unstable?
yes. For the system to be stable, all poles must be on the left side. Even if one pole is existing on the right side, system becomes unstable,
Okay, sir.
because
Understood.
that will make the system, it will object the system to go to 0. It will restrict the system. Okay.
Yes, sir.
Yes. So you can decide just by seeing the poles, not by seeing the zeros. Okay. Yeah. So now let us see this example quickly. Okay. So we have VI 1 Henry, 1 Henry. So 1 ohm, 1 Henry. So 1 farad, let's say 1 Henry plus minus V naught. Okay. So now question is to find the transfer function. Find a transfer function. Okay. So transfer function is always nothing but what? V naught of S divided by Vi of S. Okay. V naught of S is the Laplace transform of the output. Vi of S is the Laplace transform of the input. Okay. So first step is what? This is the time domain circuit. This is time domain circuit. Okay. We wanted to convert this one to the S domain. Okay. So we wanted to convert this one to S domain or Laplace domain. Okay. So what do we do is, so we write the same circuit. So let me take this circuit. Okay. So take the same circuit and replace everything with their Laplace domain elements. Okay. So this will become what? This will become LS. That will become L will be S. Okay. This will also LS. That will be S. This will become 1. This will become LS. That will be S. This will become 1 by CS, that will be C is 1. This is also 1 by CS, it will be 1 by S. Is this clear? How I write this? Is this clear?
Yes, sir, clear.
Okay, so I mean this one, why it is LS and why it is 1 by CS. And for resistor it will be as it is. For inductor and capacitor, for inductor it will be LS. Okay, for capacitor it will be 1 by CS. Okay, so if you want I can explain it for the inductor. Okay, so for example, let me explain it for the inductor so that you will understand it. Okay, so inductor, let's take like this. Okay, so let's take, we have V of t, we have I of t. Okay, inductor L. So assume that there is initial current of I naught. What is the equation here for inductor? V of t is equivalent to what? L
Di dt.
di by dt. So if you apply the Laplace transform, V of s equal to what? L into S I of s minus I of 0. Am I correct? Okay. So what is V of s equivalent to? L S I of s minus L I naught. Am I correct?
Yes, sir,
Okay.
correct.
So what is this equation? What is this equation basically? What do we have in the left side and what do we have in the right side?
Voltage equation, KVL.
Yes, voltage equation. It's a KVL equation. Okay. So if a circuit is given to us, we can write KVL equation. Now the KVL is given. Let us write down the circuit. Okay. So I of s, L s. Okay. So minus plus L I naught V of s. Is the circuit correct for that equation?
Yes, sir, correct.
Yes. Now here, so in the given circuit, no current is given here, correct? So it means that I naught is 0. If I naught is 0, what is that circuit is? This circuit, how does it becomes? That would become simply like this. Am I correct? V of s, I of s, this is Ls. Is this clear? If I naught is 0, voltage source becomes 0, short circuit. Correct? Yes or no?
Yes, sir.
Yes. So that's what this inductor I have replaced with this. Is this clear? Any doubt? So this is the time domain and this is the Laplace domain. Okay. So similarly, you can do the same thing for the capacitor also. So you can find its time domain and Laplace domain. Okay. So now what I do is, so I'm taking this is as some, this is VI node. Let's say this is a VA node. I'm taking this is as some 0 volts and that's all. So let me copy this. Okay, so I can write down the equations. Okay, so first at ith node, what is the this one? So Vi of s is equivalent to Vi of s at ith node. Okay, now at node A, what is the equation? Can anyone tell me? So Va minus Vi divided by s, correct? Similarly, this is V naught. Okay, so plus Va minus V naught by 1 plus Va by S in parallel with 1 by S equal to 0. Is this equation correct?
Yes, sir, correct. This is.
Yes. So that is at node A. Okay. Similarly, at the node 0, this node, okay, so node O. So I write the equation V naught minus Vi by S plus V naught minus Va by 1 plus V naught minus 0 by 1 by S. Is this is correct?
Yes, sir, correct.
Yes. So now we have these equations. You can solve these equations and you can find this overall expression, that is V naught by Vi. V naught of S by Vi. Okay, so I'm directly giving this expression. You can just you have these three equations. Okay, in these equations only Vi is the variable. Okay, you require V naught and Vi. So first from this equation you can write Va expression and you can substitute here. So find the final expression. So consider this as homework. So you will get that as s square plus 2s plus 2. Okay, so s power 4 plus 2s cube plus 3s square plus 3s plus 2. Is this fine? So this is the final expression, transfer function. Okay, any doubt? So these calculations you can carry out. Okay, so that is the final expression. Any queries or any queries? Okay, so so this is how you will find the transfer function. Once you find the transfer function, what you can do is, so this is your n of s, this is your d of s. Okay, so from here you can find the zeros, you can find the poles. So once you have the zeros and poles, once you have the poles, you can talk about you can plot the pole zero diagram and you can talk about whether the system is stable or not. Is this clear? Okay, so okay, fine. So we'll stop here. We'll stop here and uh, so we'll have also a small surprise test. Okay, so let me give you the question here. Everyone write it in your pace and just mail me. Okay, so take this question. Okay, so surprise test. Okay, so uh, we have spring mass damper system. Okay, so that equation is x double dot plus 2x dot plus 3x equal to 2u of t. Okay, so this is the equation, the differential equation. X double dot means dx square by dt square. Okay, so find transfer function poles, zeros, and comment on stability. This is the question. Okay, so you can take 5 minutes and do it quickly and you can mail me.
So what is in the right hand side?
Sorry, 2u of t. X is the output,
Okay.
u is the input. Yes, so I'm typing the mail ID.
What is the time limit, sir?
Yeah, take 5 minutes and do it.
The initial condition is zero, right?
initial conditions are 0. Yes. So just keep your roll number as the subject and send me that image.
So could you please repeat the equation first?
6x double dot plus 2x dot plus 3x. X is the output. Okay, 2u of t. U is the input. You have to find the transfer function, poles, zeros. Also comment on the stability. Draw the S-plane pole zero diagram. Okay, so directly comment on the stability. Which one? 6x double dot 2x dot plus 3x equal to 2u of t. X is the output, u is the input. So please submit by now the time is 6 o'clock. So submit by 6:05.
Sir,
Yes.
how I send you?
Okay, take the image and mail me that image.
Okay.
Yeah.
From our mail, from my mail.
Yes. Yes. Yes.
Okay.
Oh, sir.
Yes, yes.
So actually, I have doubts from two questions of week two. Can you solve it now?
Week two, you can mail me. We'll solve in. I'll give the reply. Not now. So you can mail me your doubts. I'll give the reply. Okay.
Not possible now.
Not now because already time over.
Or in the next class at the start of.
No. You can mail me. I'll try to give the detailed explanation. If if you don't understand, we'll connect some other time in Google Meet. Okay.
Okay.
Yeah.
Sir, one more thing. In the first class, ma'am told that some G space groups will be created. Is there any
No,
update
not
on that?
G Space group. So this discourse group, I think they have sent invitation to everyone, correct? Not G Space. There is something called as the discourse.
Okay.
Yeah, so you might have received it. Please join there. We'll be giving the, we'll be clarifying your doubts over there.
I have joined that.
Yeah.
Sir,
Yes.
Chakrabarti underscore then J or I?
Underscore J. Underscore J.
Okay, sir.
Yeah.
Sir, is it gone to you?
Yeah, I might be receiving. You can send it.
Sir, I send it to you.
Yeah, it's fine. If you're not getting, failure message, it's done. Okay. Because I cannot check everyone's now. All right. So you can leave. Okay. So please submit everyone. So we'll be ending this call. Thank you.